Welcome to Lesson 5 in the Mr. Circuit Lab on digital logic gates. In this lesson, you will learn about the OR digital logic gate. An OR logic gate can have as many inputs as needed. The one we will explain has 2 inputs, and therefore there are 4 possible combinations of input states as shown on the truth table. The first possible input combination is a 0 on the input A and a 0 on input B. The second is 0, 1. The third is 1, 0. And the fourth is 1, 1. Remember that a 0 means a false and a 1 means a true. On an OR logic gate with only 2 inputs, if either input is true, the output will be true. Otherwise, the output is false. The general rule for an OR gate is stated as follows. The output of an OR digital logic gate is true if either or both of the inputs are true. Here is a practical example. Input A is, it is windy. Input B is, it is cold outside. Output Q is, I will wear a jacket. Since, with an OR gate, if either input is true or both inputs are true, the output is true. This means that if it's windy or it is cold outside or both, I will wear a jacket. Here is the symbol for a 2-input OR digital logic gate. Look at it carefully. The symbol has a curved top and bottom with a point on the right side. And it has 2 inputs A and B on the left and 1 output Q on the right. Building an electronic OR logic gate. Here is a schematic diagram for an electronic OR digital logic gate. In this Mr. Circuit Digital Logic Gate Lab, as part of your training, you will construct this circuit on a solderless circuit board. Let me explain the circuit. You will notice that this circuit has 2 transistors, 1 LED, 3 resistors, a 9-volt battery, and 2 normally open push-button switches. As in all digital logic gate circuits, when the LED is lit up, it means that there's a true on the output. Let's talk about the transistors. Remember that when a transistor is forward biased, it means that it has the correct voltages on its pins to allow electron current to flow through it. Here we have 2 transistors. When you press switch S1, you forward bias transistor Q1. And when you press switch S2, you forward bias transistor Q2. In this OR digital logic gate circuit, the engineer designed it so that the LED will light up when you forward bias either one or both of the transistors. When you press switch S1, the current will flow from the negative of the battery through the LED and then through transistor Q1 through resistor R1 to the positive of the battery. When you press switch S2, the current will flow from the negative of the battery through the LED and then through transistor Q2 through resistor R1 to the positive of the battery. When both switches are pressed simultaneously, the path for the current is from the negative of the battery through the LED, then through transistors Q2 and Q1, then through resistor R1 and back to the positive of the battery. If you do not press any switch, the LED will not light up, which indicates a fault on the output of the circuit. So as you can see from this explanation, this circuit works like an OR digital logic gate. When either input is true, the output will be true. That is to say, when you put a voltage on the input of either transistor or both transistors simultaneously, the LED will light up, indicating a true on the output. Now that you understand how an electronic circuit for an OR digital logic gate works, you are ready to build one as part of your training, following the step-by-step instructions in the Lesson 5 booklet. Understanding these logic gate concepts will open up your opportunities into the fields of digital design and maintenance. When you complete this lab, you will be eligible to receive your certificate of electronics training that you can display and add to your resume. If you need the Mr. Circuit Lab 3, go to www.mrcircuittechnology.com. Thank you from all of us here at the Mr. Circuit Technology Company for using the Mr. Circuit Labs to learn electronics to further your career.